Alright, thanks for tuning in. This is the QAV-R 2 build from Lumenier. I'm going to walk you through all the steps necessary to get this quad up in the air. This is going to be more of a short to medium range freestyle machine running 5-inch props. So we're going to run you through all the beta flight setup, get you going on 4.0 with the RPM filtering, going to get you set up on GPS, kind of run through the new Lux F7 flight controller, and pretty much everything to get you going. So stay with us and we'll get you through the build. Thanks for stopping by. Alright, so we just got our hands on the QAV-R 2. This is the predecessor to the QAV-R 1 that came out in 2015. That was probably one of the most iconic drone frames that we've seen. It was really the most popular freestyle frame that came out when FPV was just starting to blow up on the scene. That alongside with the Alien from Impulse RC, I'd say were kind of the two most prominent frames and innovative frame designs that came out back then, a few years back. That was 4 years ago. Crazy how time flies. So this is the kit that you're going to get. It's going to come with all the fixings that Lumenier always sends. Nice packaging, all the hardware you're going to need plus extras. So we got the screws for the frame and the arms. Got some unique arm mountings on this design as they it's a kind of a nod to the original design, but it's got some nice additional features as the hobbies progress and needs have changed. So we'll get into that stuff down the road here with the tutorial. It's going to come with 4 arms. Got some unique mounting for the arms with that big gap on the inside of the arm. We're going to show you what that's for here in a second. Got your top plate, high quality carbon fiber as usual from Lumenier. You're going to pay a little more for the frames, but you're going to get high quality. So in my opinion, definitely worth it. Got the Lumenier battery strap, really good quality straps. Haven't broken one of those actually yet. Zip ties for strapping down ESCs or whatever. And then you got the bottom plate with the press nuts. So we'll get into the arm mounting design. It's got kind of a unique hole pattern there. And then you got your Lumenier stickers as usual. Alright, so step 1 is going to be kind of putting this frame together. Obviously we're going to put the arms on and the bottom plate. Going to leave the top plate off until the final step, but I usually like to kind of put the frame together and see what we got, what we're working with. So you're going to need a 2mm hex driver to start the construction process. We got a few different length screws. We got the short, the medium, and the extra long. So first step's going to be to get the arms secured to the bottom plate. Now the outside screw that you see that I'm putting on here, you're actually going to need to use the shortest screw in the kit. I started off with a medium-sized screw, but you'll see that this screw actually sticks through past the press nut. So we actually want to use the shorter length screw so that it's flush with the press nut. So we'll take our screw, we'll insert it, and then we'll tighten it all the way down. And you'll see that it's sitting flush with that press nut. And then before you tighten it all the way down, just make sure the other 3 holes line up with the arm holes, so arm holes to body holes. So we're going to take the longer screw, and that's going to be for our standoff. So we're going to take that and send it straight through the center hole, and that's going to go all the way through the press nut. So that's going to lock that in place, and then that's going to be where the standoff screws in on the opposite side. So there's a bunch of holes on the bottom of this frame. 3 screws are going to secure the arm. And then we have the 4 screw holes in the middle for the stack. So we're going to take one of our standoffs and we're going to go ahead and thread it onto this just to see how everything lines up. So we're going to thread this standoff onto the medium-sized screw, which is going to go on the other outer hole opposite of the one with the press nut. Now this one's not going to have a press nut because the standoff is going to secure it to the body. And I actually had to thread these through with a little bit of force, which is actually a good thing. So the tolerances are very tight with this manufacturing process, so that's always a good sign. It's better to be tight than loose. So you might have to thread these screws through just a little bit to make sure that it gets all the way in there, but it's going to make for a really tight fit. Sometimes you may need to loosen up the other screws to get everything to line up. So actually, yeah, so that's what it's going to look like. That's one arm on right there. And actually that middle screw that's exposed, that's going to be for our standoff for 30 by 30. If you're using 20 by 20, you're going to use those inside screw holes. So we're going to get the other 4 arms on, get everything tightened up, because once we have these on, we can start attaching the stack and the ESCs and all that good stuff. And then there's also that center screw. That's going to be to keep the arms all locked in position. So it's one screw that's different from all the others, and just make sure you put that in the middle there. So we're going to be using the Lumenier 50 amp 4-in-1. This is BL Heli 32, so we will be able to run RPM filtering with new Betaflight 4.0 Plus. Wanted to make sure that we got that going, so we got extra smooth footage on that Freestyle rig. The one thing I like about this 4-in-1 is that it has nice big pads for positive and negative on either sides of the ESC, so we can attach all our peripherals to those pads and not have to worry about messing with the actual pigtail main battery leads. I really hate having to solder on top of those, so we can have some nice clean solder pads on the opposite side for our VTX and whatever else we're going to throw on here, like LEDs that can run off the 6S battery. So we're just going to size this up and kind of figure out what the layout's going to be. So the way that those mounting screws go into the press nuts, we're going to need to put some sort of spacer in between the press nut and the component, because the ESC does touch the carbon. That's something definitely you want to avoid. You never want your components touching the carbon fiber. So we're going to try to find either some nuts or some little spacers that we can slide onto those 4 screws to start mounting our stack, which is going to start off with the ESC. So the kit does come with these nice short spacers. These are about the same size as a nylon nut. So we're going to throw those on. They're not threaded, so you just slide them on, and then we'll stack the ESC on top of those, just so make sure you have enough gap underneath the frame so that nothing is touching the carbon. And we're going to try to keep it as low as possible, so I think that this should work out just perfectly. And with this ESC, there are no, it's sized perfectly for 30 by 30, so there's no gummies, so you got to kind of use a little bit of force to slide it on there. So that looks good. We're clearing all the screws. So now we can move on to pre-tinning our ESC. And make sure you use a little flux when you're soldering. It'll just help the solder flow over the pads completely. And then once we get it all tinned up, we can move on to the next step. Alright, so next step's going to be to put our motors on. Look at these beautiful motors. These are the Johnny FPV Edition Lumenier 2207 1750 kV. This is what I'm going to be using for a 6S Freestyle rig. If you're going to be running 5S, you might want to look for the 2150 range kV motors from Lumenier. If you're going to be running 4S, I would go up to like 2450 or higher. So these motors look beautiful, really high quality build. Love the red. Windings look really high quality. So we're going to go ahead and start threading our motors on. And then once we get those threaded onto the arms, we can start soldering those up to the ESC. So the kit does come with screws for mounting motors. These arms are a little thicker than most arms. I think they're 5 mil, so if you have some, I believe 8 mil should do it. 8 mil screws should do it. Just want to, whenever you're putting your screws into your motors, just make sure for certain that the screws are not coming through and touching the windings, because that will short and fry your motor. So just be really careful and take note when you're threading your motor screws through that nothing is touching any part of the motor once you thread it through the actual motor mounts. I do recommend using Loctite for these screws. I didn't have any on me for this build, so I'm just going to skip that step. But if you have Loctite, go ahead and throw a dab on the tip of these screws before you thread them in. Alright, so now we can start kind of measuring out how much wire we need to leave exposed on the motor, and then we can trim these up before we start soldering. So we're going to get all 4 of these motors on. Alright, I'm going to be using race wire, which you can get on GetFPV. You can have the option to use the LED race wire or just the traditional race wire with no LEDs. I'm actually going to use some 6S LEDs from Tiny LEDs on top of these pads, so I opted out of the race wire LED wire. So we're going to take some VHP tape. If you guys don't have any of this stuff, this is definitely a must-have for your drone building kit. 3M is what I recommend. The clear stuff's actually pretty good. It doesn't like kind of stick as much as the gray tape, but the gray tape can be really difficult to get components off, so I find that the clear tape works just fine. For stuff like the race wire where you're probably not going to take it off your frame ever, you can go with the gray stuff, but for mounting like VTXs and receivers to the frame, I'd recommend using this clear tape because it actually is a little bit easier to remove those items if you ever have to. Alright, so we're going to go ahead and pre-tin these once we get them all stuck down to the frame, and then we can start soldering our motor signal wires to the 3 pads on the race wire. Alright, so as far as wiring up your motors, you know, the old school way to reverse motor direction was to actually reverse 2 of the wires on your motor, which is pretty easy to do with race wire installed, but honestly, you know, you can just all solder them up straight in a straight line, and then we'll go into BL-Heli 32 to reverse motor direction later on down the road. It's nice to have them all soldered up in a straight line because if you ever have to replace a motor, you always know that you can just solder them all in order and not have to worry about going into your computer to reverse motor direction. So that's one of the benefits of wiring them up in a straight series. Also, it just looks a little cleaner to have them all in a straight line. Alright, so that's our race wire soldered up. Now all we need to do to get the motors connected is to continue the wiring from the race wire into the 4-in-1 ESC. Again, we're going to wire those up in order so that just keeps everything nice and clean, and then we'll go into BL-Heli and reverse motor direction as needed. Usually you have to reverse motors 1 and 4, excuse me. So for LEDs, we're going to use these Tiny LEDs. These run off of 6S, which is really nice. You don't have to worry about running them off any regulated power. You don't have to worry about taking any of the 5-volt regulator power from your flight controller, because flight controllers are limited usually to about 500 milliamps, and LEDs can draw quite a bit of power. So if you're running your camera or your VTX off the flight controller, it's usually a good idea to keep the LEDs on a separate power system. So we're going to just use some more of that VHP tape. And these actually fit perfectly on top of the race wire, right in between those solder pads. So we'll drop those on there, and then we can just literally run the power and ground straight to the rear side of our 4-in-1 ESC, straight off the battery power. Alright, so at this step I realized that I probably want to put some heat shrink around those LEDs just to protect them. So arm removal, just want to show you guys how I did that. I just loosened up the middle screw, and then you loosen up the third screw, like the one that's closest to the middle of the frame, to remove the arm. Obviously you have to remove the outer two. So you basically remove the two screws on the outside of the arm and then loosen up the inner screws, and then you can just slide the arm out and pull it up and over that that middle screw. Basically that's why there's that big gap inside of the arms. That's so you can just slide the arm out without removing all 4 screws, and also you're able to access your screws if you're using a 20x20 stack. So I'm just using some clear 1-inch heat shrink that I got off Amazon. It's really thick and durable stuff. It's going to protect those wires as well as the LED. So we got that all shrunk down. Looks nice and clean. And so we'll do that for the other arm, and then we'll move on to the next step here. So you'll notice that I soldered on the power and ground onto the LED before I shrunk the heat shrink, and I also soldered on some signal wire for the ESCs, for the motors to the ESC. So now we're going to trim up our signal wires going into the ESC from the motors, and like I said earlier, we're just going to solder them in order. So the right will go to the right, middle, and then left to the left pad. And then if you don't have a pair of clippers, you can just kind of use your fingernails to unsheath just about, usually I do about 2 millimeters of wire exposed, and then we'll tin up those wire tips and connect those to our 4-in-1 ESC pads. For solder, I like to use a 6040 rosin core. The Kester stuff's usually the best. You can get it off Amazon. Got a big fat roll for I think $25. It'll last you a full race season at least. Definitely worth the money. It's really high quality solder. Make sure you get those nice shiny solder joints. Whenever you're soldering to 4-in-1 ESC, just be very careful that you don't get any solder splattering onto the board itself. Sometimes if you don't feel comfortable with your soldering skills yet, you're a new builder, it's always a good idea to maybe throw some electrical tape or painter's tape over the ESC components just to be safe. Make sure you don't get any solder splattering onto the components, because you can in fact create shorts on the board if a solder bead is connecting 2 components. So just keep an eye on that. If you don't feel safe, go ahead and tape over the top of the ESC there. Alright, so now we can connect our LEDs to the pads on the rear of the ESC. Those are going to be straight battery voltage. Just keep that in mind. Make sure you're not connecting any of your 5-volt components to those pads, because those will fry. This is 6S power coming off those pads. So we're going to remove this other arm and get the ESC, get the heat shrink put around that arm as well. So like I said, you have to loosen up the 2 middle screws and then fully remove the 2 outer screws. And then the arm just slides out and up. So yeah, we have to remove that standoff actually. Not a huge deal. Just take that off, and then we'll slide the arm right out. Alright, so we got both of our LEDs on the arms now. Got our heat shrink on. Now we're going to get this ESC number 3 wired up. The back left's going to be ESC number 3. Alright, so now what we're going to do is go ahead and get our LEDs wired up. So we're going to pre-tin the red and black wires coming off of our 6S LEDs, and then we can just solder these guys straight to the main power pads on top of the 4-in-1. So we'll take, let's go ahead and put this back left motor wires onto the ESC, and then we'll solder on the LEDs. Really nice thing about this ESC is that it has nice clean pads on the opposite side of the actual main battery pigtail, so you can solder all your peripherals onto those pads and not have to worry about your main leads like coming loose or popping up. So it's just a really nice feature that Lumenier added to this ESC. So we'll just solder both of the red wires onto the plus pad and then both the black wires onto the negative pad. Alright, so you can continue that same process for the top two motors. That's motors 2 and 4. Once you get that done, if you want, I decided to put GPS on this rig because it's sort of a medium to long range rig. It's always nice to have that extra comfort factor with your compass and your home direction and GPS waypoint. So if you ever lose your model, you can just look at your DVR and see the last GPS waypoint. For flight controller, we're going to be using the new Lumenier F7 flight controller. Really always love these Lumenier flight controllers. Nice labeling and very clean layout. So for the GPS, we're going to need these pads here. We're going to need 5 volts, we're going to need ground, and we're going to need TX and RX for the GPS. So just going over the different pads you have here. You got all your UARTs, and I believe that's 6 UARTs, and then it has a bunch of 5-volt pads, VBAT, camera, so it does have a built-in OSC, so you have your camera and BTX connections. So it's got everything that you'd expect from a flight controller. On top of that, it does have an F7 processor, which is really going to help us when we're running all these peripherals as well as running the RPM filtering. So we're going to use the CL and DA pads. This is going to be for your GPS, ground, and the 5-volt pad here, as well as R1 and T1. So we're running the GPS off of UART1. That's going to be the R1 and T1 that you see right there on the left-hand side. So we're using the Maytech, it's a U-Blox GPS. It's about $20, definitely the best bang for your buck, really easy to wire up. Comes with a wiring harness, so we're just going to trim up the wires and leave a lot of slack on this because we're going to mount this outside of the frame, so just make sure that you have enough slack to reach wherever you're going to mount your GPS, and then we can always twist up the wires to shorten them once we get everything soldered on. Alright, so we have on the GPS our CL and DA, which is really nice because on the Lumenier Lux F7 it has the same wordage. So you're just going to connect the green wire, which is the CL from the GPS, to the CL on the flight controller. Then we're going to take the DA, that's the white, well it's white and black because I ran out of slack, and we're going to solder that to the DA on the flight controller. And we're going to take our 5-volt, that's the 5-volt in going into the GPS, and solder that to a 5-volt out on the flight controller. And we're going to take our ground, that's the black wire coming up the GPS, and solder that to the ground on the flight controller next to the 5 volts there. Then we have our RX and TX. We're going to take the RX first, that's the yellow cable. And we're going to solder that onto the flight controller to the TX. So RX goes to TX, TX goes to RX. You want to flip those two from the GPS to the flight controller. So we've got RX going to TX1, and then we have TX from the GPS going to RX1 on the flight controller. Alright, so that's our GPS all wired up. Nice and clean, all in the same kind of area of the flight controller, which is convenient. And then, like I said earlier, if it's too long, we can always twist up the wires and figure out a mounting position later on. You can have the option of doing like a TPU mount off the rear of the quad. I see a lot of people do that, or a TPU mount on the arm. Just want to make sure that it's pointing up and clear of any carbon fiber on top of it. So we're going to be using the Lumenier. This is the new Lumenier VTX. It's got smart audio built in. It's using the TBS Tramp smart audio protocol. One really thing I like about this flight controller is that VTX, is that it does mount straight on top of your flight controller. It's got those two screw holes that basically go right on top of your stack. So your VTX will be nice and secure. And it's got the MMCX connector, which I'm really liking lately. Kind of getting away from the UFL because I've had a lot of those pop off if you don't have them heat shrunk down. So we got the MMCX on this VTX. It takes direct power. It takes up to 6S, which is also very convenient. So we're going to need our telemetry port. That's the TX there. That's how we're going to run smart audio on the VTX. And we're going to need ground and video, as well as the 5-volt, which is going to get control our camera. Actually, no, we'll run the camera off of straight off the battery. So we got the video connected. That's the yellow wire. And then we're going to take our red wire. Any sort of 22 gauge silicon wire will work for this. And then we got our black wire going to the minus pad right next to the positive there on the top of the VTX. And then we're going to take this other colored wire that's going to go to the ground. And then on the back side, we're going to need to solder one last wire for our telemetry. And like I said, that's going to go to our flight controller and allow us to do smart audio control to control our VTX through the OSD. So you're going to need 5 wires in total coming off the VTX. So let's take a look at our flight controller now and see how we're going to connect all these cables to the flight controller. So we're going to need the VTX pad. That's where the video out is going to come from. So video out to the VTX. Ground, VBAT, that's going to power our VTX. And then we'll use T3 for the smart audio. So that's going to be UART3. It's always a good idea to connect 2 grounds to your VTX if you can, so we're going to connect 2 different grounds to the VTX. Just helps for cleaner video overall. So at this point, I'm going to try to mount these 2 components, flight controller and VTX, and kind of see how everything lays before we trim up our wires. So we're going to take some nylon standoffs. These are 5mm tall, and screw those onto the flight controller to kind of see how the VTX is going to sit and what kind of clearance we're going to need. Alright, so it looks like we can actually trim our VTX wiring harness pretty short, so it's just going to sit right on top of the flight controller, so you don't need too much slack. We'll go ahead and trim and tin these 5 wires and then get them connected up to the flight controller. Alright, so we're going to take the yellow wire from the vid pad on the VTX and solder that up to the VTX pad on the flight controller. Then we're going to take our one of our grounds. We have 2 grounds, remember that's the gray wire there. Solder that up to one of the ground pads on the flight controller. And then we'll take our other ground and connect that to another ground pad on the flight controller. And then now we have to solder up our VBAT, so that's going to send whatever battery you have connected, that's going to send that voltage to the VTX. This VTX can run up to 6S, so if you're running anything 6S or lower, no need to worry about that. You can just connect it straight to the VBAT. If you're running a different VTX, it only runs off 5 volts. Make sure you run it off a 5-volt pad and not the VBAT pad there. And then we're going to take our telemetry and connect that to the T3 on the flight controller. So that's it. I really like how this VTX has solder pads and not connectors. I really don't like connectors. It makes for swapping VTXs difficult sometimes, and the connectors are prone to breaking. So I just like the cleanliness of solder pads on a VTX. It makes for really easy building. Alright, so I decided to mount the VTX on the rear standoffs, of the stack. I just secured it down with some nylon nuts on top of the 5mm nylon standoffs that are sitting on top of the flight controller. So now we're going to connect our crossfire receiver. So we have 5 volts, we have ground, and we have our RX cable. So we're going to be using one of the remaining spare UART. So we have UART 1 for the GPS, we have UART 3 for the smart audio, so we're going to be using another spare UART for the receiver. So just make sure if you're using we just use T3 for the VTX smart audio, so make sure you don't use R3 for the receiver. Make sure it's an empty UART that you are not using for any of the other peripherals. So that's it for the crossfire. We just need 3 wires. Since we're running smart audio through the flight controller, we don't need to worry about connecting any of the smart audio cables. smart audio to one of the spare pads on the Crossfire receiver. So we're going to go ahead and bind up the Crossfire receiver. If you guys aren't familiar how to do this, basically just click the bind button and then go into your Crossfire and set it to bind mode. It's pretty easy, pretty straightforward. There's a bunch of videos online if you guys don't know how to do it, so we won't dwell on that too much, but usually you'll have to update your receiver if it's brand new, and just make sure you go through that process. So once you have your receiver bound up, we can go ahead and start figuring out where to mount it on the airframe. I'm just going to use some double-sided tape, clear VHP tape again, and just mount it in the rear. Plenty of room in this build for mounting stuff, so you can kind of pick and choose what you want. I like to keep my Crossfire away from the camera because I have noticed that it can cause some video noise on the camera if it's sitting right underneath the camera there. So we're just going to mount it in the back, and that's going to give us easy access to the Immortal T sticking out the rear. Make sure we have enough slack to reach that rear 3D printed Immortal T mount that you can get from Lumenier with the kit. Alright, so we got our Immortal T mounted on the rear mount. We have our UFL on the Crossfire Nano RX, and plenty of slack to make sure we're not putting any stress on that UFL connector. So that's looking good. Now we need to get the SMA connector from the VTX threaded through. Before we do that, sometimes I like to add a little bit of solder to make sure that the UFL and the Crossfire antenna do not move around. Another option to do is just to put heat shrink around that whole receiver with the antenna mounted on there. But I like to use a little bit of solder. Heat shrink is also probably a better option, honestly, because it makes swapping antennas easier, but then you have to cut the heat shrink and put another piece of heat shrink on. So I just usually solder it on. So for an antenna, we're going to be using this new Lumenier Axi Long Range. This thing's awesome. Extends the range of your antenna, just to make sure that you're clearing the frame, clearing the battery, and getting a nice clean video feed from your VTX to your goggles. So we're going to take the SMA and thread it through the rear hole on this 3D printed mount. You might have to take off the mount to get it through. Might be a little difficult with it mounted onto the frame. Once you have it threaded through, take that nut that comes with the SMA mount and make sure you tighten it all the way down so it's nice and secure and not going to move around while you're in flight. And then we can screw our antenna on. When you screw the antenna on, just make sure that the antenna is tight and that it does not spin around the base. That means that you have a nice and solid connection. If the antenna is spinning when your SMA is screwed down, that means that there's not enough thread on the SMA coming off the VTX, so you might need to thread it through a little bit more through that hole to make sure that you got a solid connection on that antenna. Alright, so we're on the home stretch now. We can go ahead and get the hardware to mount our top plate. You're going to need 8 of the short M3 screws that come with the kit. Just make sure you carefully thread the carbon notches through from the camera mount to the top plate, and then go ahead and screw in those 8 screws to secure the top plate. And then make sure you throw on that battery pad, that foam battery pad. That's really going to help your battery from moving around in flight, and if you have a crash, it's really going to keep it tight in place. So that's definitely throw that on top of the top plate. Now I took a couple of the zip ties that come with the kit, and I zip tied the battery pigtail to the top plate just to make sure it's nice and secure, and just keeps it clean and out of the prop line. And just make sure that you have enough slack to connect to the battery, however you're going to mount the battery. For this frame, I recommend just doing the traditional top mount, long ways style, and you have the option to put 2 battery straps through here. It's up to you. You know, if you want to save a little bit of weight, throw 1 on there, but if you want your battery to be really secure, go ahead and put 2 on there. So we're using these Lumenier Kevlar reinforced straps. These things are awesome. Have yet to break one yet, so they're gonna last a long time, and make sure your battery stays on in a crash situation. So we got the GoPro Hero 6 and 7 mount. I believe the 5 will fit in here as well. This mount comes with the kit as an option. It's a very nice 3D print, fits in there nice and snug, and you just need to basically use the front 4 screws that secure the top plate to secure the GoPro mount. So you're going to screw through the mount into the top plate and then into the standoffs. Alright, so we are pretty much done with the build now at this point. We just need to secure the GPS to a part of the airframe that's not going to be blocked by anything. So I'm going to put it on the front left arm there. I'm going to actually put 2 battery straps on. When you strap it through, just make sure you're not pinching any wires. So I'm going to stick it right under the battery pigtail, on top of the battery pigtail underneath the top plate. So just be very careful that you're not pinching any wires or pulling on any wires when you strap your batteries strapped through the frame. And then you can always do a test fit, make sure the battery strap's in the right place, but you can kind of adjust them on the field as you need. We're going to be using the 1350 MOS 6S NO2 batteries from Lumenier. These batteries are really high quality, top-notch batteries. Going to get about 5 minutes of cruising flight time on this frame. 3 to 3.5 minutes of just kind of sending it freestyle with this guy. So plenty of flight time, nice big pack, a little heavier, but you really won't notice it if you're just doing some freestyle runs. Alright, last step's going to be to secure our GPS to the arm. One of the options you could do is to just VHB it or Velcro it to the top of the GoPro mount, just to keep it safe from any prop strikes. I'm gonna put it on the arm because I'm gonna use this quad for more like long range style stuff. So if I don't plan on crashing it too often, so I'm not really worried about the GPS kind of on the arm under the prop. But definitely safer spots can be on top of the GoPro if you feel like you need to do that. So that's it. The build is done. Now let's go into Betaflight and do all that setup for this guy. Alright, so we are going to show you now how to get Betaflight 4.0 running and get all your ESC RPM filtering going. So this is the new way to basically run your quadcopter on the newest Betaflight, taking advantage of all those new features like RPM filtering that are really going to make your quad fly a lot better. So first step's going to be to figure out what the target is for this flight controller. And then we're going to go into the Update Firmware tab, and we're going to find the Maytech. That's the board that we just saw in the CLI. We'll do a full chip erase, we'll load the hex file online, and then we'll flash the firmware. So I'm going to include a link in the description to my website, sfpvr.com, where we have a whole blog post about how to run RPM filtering in the latest Betaflight 4.0. So if you go to my blog, you're going to look for Betaflight 4.0 RPM filter setup. We just did step 1 where we flashed the latest version. Now we're going to go to step 2 where we're going to look for a specific hex file for the ESC that we're using. Keep in mind that you must use a 32-bit ESC. So we're going to open up BL Suite. From there we're going to go ahead and connect. Just make sure you disconnect from Betaflight before you try to connect in BL Heli. And then go down to the COM and select the USB serial device. So now that we're connected here, we can go ahead and read setup, and then from there we'll be able to figure out what the actual name of our ESC is. So you can see there it shows the name of the ESC, and then we go to this list in the link on my blog, and you can actually match up the exact name. Make sure it's the exact one, it's really important. So we're going to find it on the list. If it's not on the list, then that means that you're unable to do it. But for this build, this Lumenier 32-bit 4-in-1 is available. So we'll go ahead and just confirm that we have the correct one on the list. We'll download that file, and then we'll click on let's download the right file, Cycon ST, and then we're going to click on the raw. Right click on that, save it as a hex file, and then from there we'll go into BL Heli, go to flash, and then ignore, and then pick it. So you're going to click ignore, pick file from a list, and then go wherever you save that raw file to, that's where you're going to click on, and then go ahead and hit yes and start flashing the ESCs. So you're going to need to run through this process for the next 3 ESCs where you ignore and pick file from a list, and you're just going to have to click on that file that you saved from GitHub. It's a little hard to follow in this video, but I promise you if you go to my blog post, you'll be able to figure it out pretty quickly with all the step-by-step links and guides. Alright, so we have flashed all 4 of the ESCs. Now we're going to move on to step number 3. Sorry, so I had the ordering wrong but for this video, but actually my blog it's correct. So step 4 is actually step 3. So we're going to click on that link, and we're going to scroll all the way down to the bottom, and we're going to find our flight controller, the Maytech F722 SE. Click on new, and then we're going to copy all of this text, and then we're going to paste that into the CLI in Betaflight. And then just go ahead and hit enter, save that. Flight controller is going to... Alright, so now we're going to go to step 5 and do some tuning. I'm just going to use my it's kind of standard tuning for Betaflight 4.0 and higher. So we're going to go ahead and go into PID tuning and turn off the first 2 filters on the left, and then leave the first one on the right hand side, then turn off all the other ones. This should fly pretty solid if you have a brand new build. And then for PID tuning, I'm just going to use my standard smart feed forward on, feed forward transition on, I-turn relax on. And we'll put the acro chainer angle limit to 20, and then we'll put feed forward transition to 0.3. That's what I found to be the best. And then we'll just get our rate set up. Alright, so if you go to getupv.com, and they have a really nice manual for this flight controller. One thing we need to do is go into the CLI and figure out which MCU is being used. So we're gonna follow the guide on the for the flight controller, and we're gonna set it to let's see, gyro to use equals first. So we're gonna first get figure out which gyro is being used. So we're gonna type get gyro _to use. Right now it's set to first. So we're just gonna set it to second. Alright, so now we're just gonna do our general beta flight setup. So we're gonna make sure that the accelerometer is positioned correctly. So we'll go into the setup tab and move the quad around and just make sure it's aligned properly. If it's not, you go into board sensor alignment on the right hand side of configuration up towards the top, and then we'll just kind of adjust it as you need. Usually you just have to rotate it 180 degrees on the yaw, and that should do it. Make sure you reset the z-axis when you're checking to see if the board alignment is correct. Once we do that, we can turn accelerometer off if you're not going to be using angle mode or anything like that. If you're just going to be flying straight manual, turn the accelerometer off. It'll save some of the processing power of the flight controller. And since this is an F7 board, we're going to be running 8. Alright, so we're actually going to run D-Shot 1200, D-Shot 600, or 1200, either way. Try it out on 1200 if you're getting some weird flight characteristics. Drop it down to 600 for the RPM filtering. So we got to turn on GPS, and we're going to select the U-block, MSP GPS. Or actually, let's double check what this one actually is. Looks like it's a U-block, so select U-blocks, and then that way we'll get GPS coordinates and all that good stuff. So once you have the GPS all set up, you can put whatever you want in your OSD, like the latitude, longitude, the home arrow, and the satellite icon on the top left. Just keep in mind, if you're indoors on the bench working on your quad, it's not going to pick up any satellites most likely, so it's probably working. Just take it outside, give it a few minutes, and make sure you're getting satellites showing up on the GPS. Alright, so now that we're just going to check to make sure that smart audio is working. So to get into the OSD menu in your goggles, you're going to hold throttle mid, then yaw to the left, and then pitch all the way up to the top. And then we can go into features, and then VTX Tramp. It's not smart audio, it's not TBS, it's going to be Tramp. And then we can go ahead and change the channel through there and make sure that it changes in the goggles. So you should lose video if you change channels, and then go ahead and make sure that it went to the correct channel, and then we can just save and exit from there. Alright, well that does it for the full build guide. If you guys have any questions, as usual, go ahead and just leave a comment on this video. Hit me up on Facebook as well. Happy to answer any questions through direct messages. If you guys get stuck anywhere, I know it can be kind of complicated, especially if this is your first build, getting the GPS working, all that good stuff. But if you get the Lumenier Lux and the Lumenier ESC, the pinouts for the cabling all match, so that's a really easy step that you can kind of make the build easier, as well as the Lumenier VTX. Crossfire can be a little tricky, so there's a bunch of videos on there getting that set up and all bound and getting your settings all right. But yeah, if you have any questions, just hit me up. Happy to help, and hope this build goes well for you guys, or if you learned something on the RPM filtering or anything else that we covered in this video. All right, happy flying.